Lesson 221 and 222, interpreting key features of a quadratic function. We're going to label whether these are even or odd, where they are increasing and decreasing, and state its domain. Okay, so I'm going to jump straight to example number 1. Okay, so example number 1 asks us to identify or interpret the increasing and decreasing levels, understand the domain as it relates to the scenario, and then here's our scenario here. So we have a scenario of a local store's monthly revenue from t-shirt sales is modeled by the function. Okay, so we can go ahead and start labeling our graph. So we know the x-axis is going to be t-shirt sales, right? And that's the price per the t-shirt sale. And then our y-axis is going to be revenue, and that'll be mentioned a little bit later, right? So revenue, the amount of sales we have. So we're given our quadratic here. We have f of x equals negative 5x squared plus 150x. So first thing we want to do is we want to go ahead and graph this quadratic, right? And we all know how to graph, and if not, you can always refer back to the videos from the earlier lessons in Unit 2. So if we're looking at this, we can tell that this is going to be ax squared plus bx plus c. So this is our quadratic in standard form, right? So then we could do our 5-step method to go ahead and graph this, right? We have our, first we state whether it opens up or down, and we look at our A. We know it's going to open downward. Then we do our vertex, line of symmetry, y-intercept, and then our strategic point. Okay, for the sake of saving time, I'm going to go ahead and use Desmos because we're more concerned about answering these questions down here for this lesson. Okay, because we already did our practicing of the graphing, and we all should know how to graph by now. So again, if you can't graph these by hand, you got to go back and look at those lecture videos from earlier in Unit 2. So I have here, I use Desmos to go ahead and plug our function in. So here's our graph for our function. Okay, and again, this is just to save time, and on the test you will be expected to go ahead and graph these on your own. Okay, so we have our x-intercept here of 0, 0. We have our vertex of 15, 1, 25. And then we have another x-intercept here of 30, 0. Okay, so now going back to the questions that it's asking. First question here is, at what price is the revenue increasing? So where do we have our increase? So now if you look at our graph, we read our graphs from left to right. So we're starting from the left. So if we're starting from here at 0, 0, and we're reading our graph, we follow our graph, we notice that our graph is going upward all the way up until we reach the vertex. So here we have an increase, right? So again, reading from left to right, our graph is increasing. The increase occurs from when x is 0 to all the way when x is 15, right, where our axis of symmetry is. Right, so from 0 to 15 is where, let me try to fit that 0 in there, where our increase is. And now to notate this, when we go to our graph, we want to state that our increase was from 0 to 15. Okay, so that's how we state that from 0 to 15 we had an increase. So 0 is less than or equal to x is less than or equal to 15. Okay, so that notates from on the x-axis, right? It's telling us on the x-axis that from 0 to 15 an increase occurs. And now we look at our decrease. So again, when we go back to our graph, we start looking at our descend. So this is our maximum, our vertex is our maximum there. So after we hit our maximum, we start our descend, and we're decreasing. Okay, and a decrease occurs all the way up till 30. So if we're looking at from 15, right, because that's where our vertex is, that's where we start our descending. So from 15 to 30, we have a decrease. So our decrease starts at 15 and goes to 30. So from 15 to 30, between 15 to 30, we have our descend, we have our decrease. Okay, now we're looking at our next question. Right, so what is the maximum revenue? So maximum revenue is where we make the most money. So if we're looking at the max revenue, we go back to our graph. Well, our max revenue occurs right there. Right, and we're looking at the y-axis, and that is 1,125. That's the highest our graph goes. That's the maximum our graph goes. So the most amount of money we can possibly make is if we price our shirts at $15, we'll make a maximum revenue of 1,125. So when we go to answer this, our max revenue, possibly if we price it at $15, it is $1,125. Okay, next question. What prices yield no revenue? So where do we make no money? So no revenue. And again, we got to refer back to our graph. We're going to be reading our graphs a lot here. So no revenue is when the y is at 0. So if we're looking at this, we look for our x-intercepts. So right there, y is 0. And at 30, y is 0. So this is telling us that when we price our shirts at $0, right there, so when we price our shirts at $0, we make 0 revenue, which makes sense because if you're selling something, you're giving it away for free, you're not going to have any income. Okay, so that first one, our first no revenue is there at 0, 0. So when I go to put this down, so first revenue was when we price our shirts at $0. And then we do have another one here at 30. So if we price our shirts at $30, our consumers are saying, hey, our shirts are too expensive. We don't want to buy any of it. So when we price our shirts at $30, people are saying it's too expensive and nobody buys them. So we have $0 in revenue there as well, just because our shirts are too expensive. Okay, so no revenue at $0 and $30. And again, those are our x-intercepts. Okay, and now the domain. So if we're looking at domain, okay, and again, this is going to relate to the x value. So it says, what is the feasible domain of the function? So if we're looking at a function here, so remember that the x-axis stands for t-shirt sales, right? So the price of the t-shirt sales. So if we price it at $0, it's possible to have a $0 shirt. So now if we go here and we look at -10, it's not possible to price a shirt at -$10. Right? It's not possible to price a shirt at -2, -4, -6, -8. It doesn't make sense. You can't price a shirt at negative numbers, so we don't use any of this data here on the left-hand side of 0. We don't use any negative numbers. Now, at the same time, if we're looking at revenue, if we're looking at the y-axis here, right, the vertical, if we're looking at the y-axis, it doesn't make sense that if we sell t-shirts, we have a negative revenue, so we don't use any of the negative on the y-axis, right? So we're just restricted our graph from 0, 0 all the way to right there, our other x-intercept. Okay, now we need to notate this. We have to do the same way we did with increasing and decreasing, right? Because it's not going to make sense if this graph goes any further down this way, so we have to cut it off right there. And again, we start at 0, 0. So our domain stretches from 0 all the way to 30, because that's the only place where our graph makes sense. So our domain is from 0 to 30, right? So 0 is less than or equal to x, is less than or equal to 30. And again, answering these questions is just a matter of reading the graph and understanding the graph, right? So this one had context. We had a scenario, so we had to restrict the domain, so the scenario makes sense. Okay, now going on to example 2. So example 2, we notice we don't have a scenario here. So just going straight to the question, right? I'm right here. It says a function has a minimum value of -5, right? So a function has a minimum value of -5 and x-intercepts of -8 and 4. So far, I can plug in my x-intercepts of -8 and 4. I know exactly where those are on the graph. So I can go here to -8. That's one of my x-intercepts, and 4. That's my other x-intercepts. Okay. Now it asks, what is the value of x that minimizes the function? So now keep in mind that minimums occur at the vertex. So what this is asking us to do is kind of solve for the vertex. Now we know that parabolas are, since we have a minimum value, we know it's going to be opening upward, and we know that parabolas are symmetrical, right? So that halfway point in our parabola is our line of symmetry. That's where we reflect each point. So now if we have two x-intercepts and we know that these are both the same distance away from the axis of symmetry, we know we can use the formula p plus q divided by 2, right? And that we know from the factored form of our quadratic. We take our intercepts, add them together, divide by 2, and we have the x value of our vertex. So our p is -8 plus 4 divided by 2. That simplifies all the way down to -4 divided by 2, which is -2. So now the x value of our vertex, the x value is -2. Okay, and then that first piece of information that was given to us, right, has a minimum value of -5. Remember, the minimum occurs at the vertex. So that is going to be our y. So -2, -5 is a point for this function here. Okay, and that is where we have our axis of symmetry. And I'll go ahead and I'll make this dotted somewhat. Okay, so now, just for the sake of saving time, we have enough points to answer the questions that are presented. So I'm just going to go ahead and go straight to answering the questions. Okay, so notice that I put these arrows here because we don't have a scenario for this question, so we don't have to restrict the domain. It's just a regular parabola, no scenario. It goes on forever. Okay, so I'm going to go ahead and erase this here so I have enough room. And I had, oops, sorry about that. Okay, so now we can go straight to answering our questions. For what value of x is the function increasing? So if we're looking at the increase, so if we start off our graph, it starts off with a decrease, right? And it decreases all the way up to the vertex over here at -2. So it starts with the decrease, and then it goes up, increasing after the vertex occurs, right? After at the vertex right there. So our increase is from -2, right? It starts at -2. So -2 is less than or equal to x is less than or equal to. So remember that this parabola is going to go on forever. So we state that it goes on to infinity. And we make our infinity symbol like that. Okay, because remember, parabolas are never ending unless we have some kind of context. Okay, now it's asking for what, let's see, decreasing. So for what values is it decreasing? And we look at our x-axis. So we have a decrease coming in from -infinity, right? Because this is going to go on forever. So from -infinity, it's decreasing all the way to, and again, it's that vertex spot, -2. Okay, so it's kind of like a little flipped around. Another way we can also state these, so we have our increase for all numbers after -2. So we can just say, if you choose to do it this way, this is fine too. X is greater than -2 for all values greater than -2. So if we're looking at values greater than -2, that includes -1, 0, 1, 2, 3, 4, 5, and so on. And then same thing goes for decreasing. So decreasing, it is all numbers less than -2. So if we're looking at -3, all these values give us a decreasing interval, right? Because it's all going down. Okay, so that's just another way you can write it. They're both correct, and you will get full credit whichever one you present to us on your exams. So the last question here, what is the domain of the function? So if we're looking at domain, remember domain is all values of x it can possibly be. So remember that this goes on from -infinity all the way to +infinity. Oops, that's a horrible infinity sign. To +infinity. Okay, so remember, these go on forever, right? So they're going to be part of every single one of these negatives and every single one of these positives. So our domain is from -infinity to +infinity. There aren't any situations that are given to us where it would restrict our domain. There's no context to this parabola. So the domain doesn't ever stop. The parabola never stops. Okay, and then our last example here, we have example number 3. So understanding the differences between even or odd functions. Okay, so looking at an even function, so this is when we put in, if I can write, so this is even occurs when f of x, when f of x is equal to the function of -x. Okay, and here's what that means. So if I'm looking at 1, right, so that's f of x is +1. F of -x means the opposite of 1. So I'm looking at the function of -1. So if we're looking at the function of both of these, so if I put, let's say, f of 1 equals f of -1. So now we see if these make sense. So at 1, our graph is at 1. At -1, our graph is also at -1. That is a even function. Okay, so when you put the opposite of a number and you get the same value, right? So f of 1 equaled 1, f of -1 equaled 1. Okay, all that means is that our parabolas are symmetrical, right? You can reflect them over the y-axis and it'll be at the same spot. So if we take 2, which is at 3 here, let's say it's at 3. If we go to -2, it's also at 3, right? It's reflected. It's a perfectly reflected point over the y-axis. So that's how we know a function is even. If we can take it from one side of the y-axis, fold it to the other side, and get the same picture at the same location, that is even. So this here was even. Now looking at odd functions. So odd functions, I'm going to write this here, is when we take f of x and it equals the negative f of -x. Okay, so f of x, let's say I choose 1. So for f of x, I choose function of 1. Now, the opposite of the function, so instead of 1, for this one, it's going to be -1. Okay, so now what this is telling us is if I choose 1, let me do that in a different color. So if I take the function of 1, I get -1. So now if I'm taking the negative function of -1, it tells me that it should be the opposite of -1. So we have to check. So the function of -1 is 1. And that is the opposite. So this here tells us that it is odd. Okay, when you choose the opposite x and get the opposite y, you have an odd function. Okay, so for all these values, so for 2, so if we're looking at 2, you get, what is this down here, -8. So now if you choose -2, you should get a +8. You should get the opposite outcome. Okay, so this one is rotated about the x-axis, right? So it's coming there. It's coming there. Okay, so it's kind of like you're folding it and flipping it at the same time. And those are going to be your odd functions. Now, if it doesn't come out to be either of these, so if we're looking at this here, this top left one, we notice that it is not reflected about the y-axis, right? If we reflect it over the y-axis, it doesn't give us a perfect symmetrical parabola, so it's not even. And now if we're looking at the opposite numbers, let's say we look at 2. At 2 we have -4. And then at -2 here we have, it looks like a number off the graph. It's not the opposite, so it's neither even or odd, so this is neither. Okay, and now same goes for this one down here on the bottom left. So if you reflect it over the y-axis, it's not going to be the same picture. This one's going to go like that and like that. Okay, it doesn't give us the opposite picture, so this is not even. And again, if we're looking at 1, we get -3. If we're looking at -1, we get -1. So this is neither as well.